For most of human history, launching a rocket meant losing it forever. Decades of space travel followed a simple rule. Rockets were disposable. Once they burned through their fuel, they crashed into the ocean or were left drifting in space as debris. This made spaceflight insanely expensive. Then, in 2015, SpaceX did the impossible. They launched a rocket, brought it back, and landed it upright. For the first time ever, a 14-story booster returned from space, touched down safely, and was ready to fly again. How did they pull this off? What kind of engineering genius made it happen? Today, we're breaking down the mind-blowing technology behind SpaceX's rocket landings. The challenges of landing. A rocket landing. A rocket isn't like landing an airplane. When a commercial jet comes in for landing, it slows down gradually, glides through the air, and touches down on a runway. The wings generate lift, and the wheels absorb the impact. Rockets don't work that way. First, they travel at extreme speeds. Falcon 9 reaches up to 17,500 miles per hour when in orbit. Second, they don't have wings to help them glide back. Instead, they fall from the sky like a giant metal tower. And third, they have to land with pinpoint accuracy. If the timing is off by even a fraction of a second, the rocket will either crash or tip over upon landing. For decades, space agencies thought this was impossible, but SpaceX was determined to figure it out. The science of propulsive landing. SpaceX's landing technology is based on a concept called propulsive landing. Instead of using parachutes, gliding, or crash landing into the ocean, Falcon 9's booster fires its engines in reverse to slow down and land vertically. This is extremely difficult for one reason: fuel efficiency. A rocket needs almost all its fuel just to reach space, so there's barely any left for landing. This meant SpaceX engineers had to make their landings as efficient as possible. To achieve this, they developed a landing sequence that works in 3 stages. The first stage is the boost-back burn. As soon as the Falcon 9 booster separates from the upper stage, it flips itself around and fires its engines to reverse its direction. This ensures it doesn't continue drifting deeper into space. The second stage is the re-entry burn. As the booster falls back toward Earth, it's still moving at thousands of miles per hour. If it entered the atmosphere at full speed, the air resistance would destroy it. So, it fires its engines again to slow itself down before re-entry. The final stage is the landing burn. In the last moments before touching down, the rocket fires its engines one last time, slowing itself to just a few miles per hour before gently landing upright. This sequence happens in just a few minutes, requiring split-second precision. Even the smallest miscalculation means failure. The role of grid fins. Another critical piece of SpaceX's landing technology is the grid fins. These are 4 metal fins mounted near the top of the Falcon 9 booster. They don't look like much, just a set of metal grids about the size of a table. But they play a crucial role in guiding the rocket during descent. As the booster falls back to Earth, the atmosphere becomes denser and air resistance increases. The grid fins allow the rocket to steer itself by adjusting how much drag is applied to different parts of the booster. They work like the rudder of a ship or the ailerons of an airplane, helping the rocket stay stable and on course. Without grid fins, Falcon 9 would have almost no control over where it lands. Precision landing on a drone ship. Landing on solid ground is difficult enough, but SpaceX often lands its rockets on floating drone ships in the middle of the ocean. Why? Because not every launch has enough fuel for a return-to-land maneuver. When Falcon 9 carries heavy payloads to space, it doesn't have enough extra fuel to reverse its course completely. Instead, the booster has to land on a drone ship positioned hundreds of miles offshore. These drone ships are fully autonomous, using GPS to stay in the exact position needed for a successful landing. Even though the ocean waves may be rocking the platform, Advanced stabilization systems keep it steady. Still, landing on a moving target in the middle of the ocean is incredibly challenging. SpaceX's early attempts failed spectacularly. The boosters either missed the drone ship entirely, tipped over after landing, or exploded on impact. But after years of trial and error, they perfected the technique. Today, drone ship landings are routine, making spaceflight more flexible than ever. Rapid reusability, the key to SpaceX's success landing. The rocket is just one part of the equation. The real goal is rapid reusability, being able to relaunch the same booster again and again with minimal refurbishment. This is what makes SpaceX different from any other space company in history. In the past, rockets had to be rebuilt from scratch for every launch, making space travel slow and expensive. But SpaceX's Falcon 9 boosters are designed to be reused multiple times. Early on, reusing a booster took months of work. Engineers had to inspect, refurbish, and retest nearly every part. Now, SpaceX has streamlined the process to the point where a booster can launch, land, and fly again in just a few weeks. Their ultimate goal is same-day reusability, launching a booster in the morning and flying it again by evening. This will revolutionize space travel, making it cheaper and more accessible than ever before. The future, Starship and beyond. Falcon 9 was just the beginning. SpaceX's next-generation rocket, Starship, is designed to be fully reusable, both the booster and the spacecraft itself. Starship will use an even more advanced version of SpaceX's landing technology, with precision-controlled thrusters and heat-resistant tiles for re-entry. If successful, Starship will make interplanetary travel possible, allowing humans to land on Mars, return to Earth, and fly again. This is the ultimate vision. Rockets that are as reusable as airplanes, reducing the cost of space travel to a fraction of what it is today. And it all started with Falcon 9's first historic landing. Call to action, SpaceX has proven that landing rockets is no longer science fiction. It's a reality that is changing the future of space exploration. But what do you think? Will Starship make rocket landings even more advanced? Or will another company step in to challenge SpaceX's dominance? Let us know your thoughts in the comments. And if you enjoyed this deep dive, make sure to like, subscribe, and turn on notifications so you never miss out on the latest space and technology updates. Thanks for watching, and we'll see you next time.